While discussing about the safety life cycle, we have discussed about the various steps involved in the safety life cycle. First of all these steps is hazard identification. Because any safety assessment or any safety loop, first we need to assess the hazard, then only consequent work can progress. A safety function is totally useless if it is not linked with any hazard, right? You have developed a safety function consisting of sophisticated instruments, but that is of no use if it is not mitigating any risk or any hazard, which may be explosion, fire, fatality, or maybe leakage from the pipe, or overpressure scenario, over temperature scenario. So whatever system you design, it should be designed to avert some risk, to prevent or mitigate some hazard. Another point here is worth mentioning is safety instrumented system are not based on the hazard which are over dimensioned or over specified. At the same time, it is not designed for the hazard which are under specified or under dimensioned. I mean, there can be hazard which can be of no particular significance, right? So there might be some hazard, but that not really affect anybody, or uh, the severity of the hazard is very low. So we will not consider that type of hazard. And again, this if the hazard is very high, uh, in that case, safety instrumented system can alone cannot prevent that kind of hazard. So again, if hazard rating is very high, in that case, safety instrument system cannot do anything, or safety instrument system are not designed for this over specified or over dimensioned hazard. Now there are multiple techniques in hazard analysis, like checklist analysis, what if analysis, failure mode and effect analysis, hazard and operability studies. So all these different techniques are used based on the gravity of the problem and the function or the process. So if you are going through a simple process, and that only need to have certain kind of checklist in it to identify the hazard. Like a technician is going to the field, and he needs to assess the risk associated with any particular job. So there will be a certain kind of checklist will be there. So that checklist will identify that whether there is any hazardous substance is present there or not, whether the gas test has been done. So like the one you have seen attached to the permit. So that is basically checklist. So based on the checklist, you assess the hazard. Second is what if analysis. So what if analysis is done for in some cases like simple process modification. If the process modification is very simple, not very complicated, not so many things are involved there. Maybe you are rerouting a line to somewhere or similar kind of thing, but sometimes the what if analysis can also provide results which can be very significant. If you find any result that are very significant, then you should further go ahead with the hazard and operability study to have much more conclusive hazard analysis. Then there are failure mode and effect analysis. So this particular is method is very popular and used for wide range of industries, and it is used for product, process, and systems. So this is another technique we will discuss about this failure mode and effect analysis and hazard and operability analysis in much more detail in subsequent lectures. So for any kind of hazard analysis, we will be needing a certain kind of information, and I have tabulated some of the information here. For example, physical environment, the environment in which the system or the product or the is involved. Material characteristics, what of the material that has been handled. The equipment under control, whether it is a compressor or a pump or anything other than this. Then what kind of basic process control is available there, whether there is any basic process control is available to regulate the temperature, pressure, etc. Whether there is an alarm function that is available in the SCADA DCS, or is there any notification that is generated to operator. And we also need to check what are the existing safeguards already available, whether there is a pressure relief valve, whether there is a fire and gas system that is available in case of tank, whether there is a dike wall that is available. So all this information are basically required to do any kind of hazard identification studies. So this particular lecture just gave a brief overview why hazard identification is important, and also what are the different techniques that can be used to identify the hazard. In the subsequent lecture, we will be discussing about uh, detail about each of the techniques like what if analysis, hazard and operability study, and FMEA. Thank you.